My name is Stephen Smathers, and I'm the president of Perfect Lens. Perfect Lens is a research and development company located in Irvine, California. Perfect Lens does not manufacture a lens. What Perfect Lens has done is they've developed a device and a technology that enables Perfect Lens to alter the refractive characteristics of an already implanted lens. The device fits easily in the doctor's office, and it uses a femtosecond laser to alter the IOL. Let's talk about the technology. What does it do? We can adjust all acrylic IOLs, hydrophilic and hydrophobic. We can alter sphere and cylinder. We can add multifocality, and we can remove multifocality from the implanted lens. The ability to treat the lens is based upon a repeatable and reliable chemical reaction which we create within the acrylic lens using energy from the femtosecond laser. Potentially, you can adjust the IOL multiple times, and you correct issues that are caused by surgical error, incorrect measurement, or post-surgical movement of the lens, decentration or tilt. There's absolutely no cutting or ablation of any tissue at any time. This is a completely in-office procedure. It takes 45 seconds or less and potentially can correct higher order aberrations. The basis of the change is a photo-induced hydrolysis within the polymeric material initiated by the energy from the femtosecond laser. The hydrolysis produces hydrophilic molecules which draw water into the polymer matrix. These water molecules reduce the refractive index of the implanted lens, and then by strategic positioning of the water molecules, we're able to alter the diopter and the optical characteristics of that lens. What we have here is, on the left, this is the pattern that we would use to make a spherical correction, but the one on the I guess that's the other left. The ellipse is the pattern we would be using when you make the more common correction, and that would be a toric and a spherical correction at the same time. The procedure is the same whether it's just a sphere or sphere and cylinder, or sphere, cylinder, and multifocal. This is just one of the examples of the in vitro studies we did with respect to this particular technology. We were attempting to alter these lenses by about 2 diopters. The mean alteration was 2.03 diopters with about 95% of the existing MTF. Our focus for 2019 as we developed this technology has been threefold. One, to make sure we are transmitting all the light that was being transmitted before the treatment. 2, making sure we don't have any halos or glares or we're creating any visual abnormalities. That we are identifying the right energy levels for the human treatment, and making sure that we adequately adjust our formulas to deal with energy absorption from the cornea or the capsular bag, the aqueous humor. Whoops. Well, let's see. There we go. This is the results of a transmission study done by the Moran Eye Center. You'll see that virtually 98% of the light that was being transmitted pre-treatment is transmitted post-treatment. This is a chart of energy utilization. It appears that the appropriate energy utilization for this treatment will be about 0.1 to 0.2 watts per square centimeter. You'll realize how low that is. And we've engineered the device to be able to make the treatment and to adjust the lens at that level. Finally, here we have the efficacy variables, which we are dealing with and have come up to some adjustments which allow us to adjust for corneal and aqueous humor absorption. I appreciate your invitation, George. We're very excited about what's going on. We're in the midst of human trials, and we're very optimistic. Thank you.
Steve, thanks so much.